Hey, what's up, my fellow adventurers of the future? You've just tuned in to another mind bending episode of Paradox Hour, where we break down the wildest, coolest, and sometimes most confusing science and tech ideas so you can sound like a genius the next time you drop a comment in a group chat. I am your host, and today we're unlocking the secrets of light. Now, I know what you're thinking. Light? You mean like the thing that lets me scroll TikTok at 3 a.m.? Well, yeah, but it's so much more than that. Light is the ultimate sci-fi energy, the thing that connects us to the stars, tells us what's going on in space, and yeah, helps you check your Insta likes. But trust me, light is way more epic than just lighting up your room. It's literally how we all understand the universe, and maybe even why you can't find your keys in the dark. Spoiler, that's not on the universe, that's on you. All right, so let's break it down. First things first, light is part of something called the electromagnetic spectrum. Think of it like a massive Spotify playlist, but instead of songs, you've got different kinds of waves. And the track we humans can see is smack dab in the middle. Visible light. That's your ROYGBIV. Red, yellow, green, blue, indigo, violet. Basically everything you see in a rainbow. But here's where it gets cooler. There are tracks on this playlist you can't see. Infrared, ultraviolet, X-rays, and gamma rays. They're all invisible to our eyes, but they're just as real as that notification that just popped up on your phone. So while we're only jamming to one part of the spectrum, the universe is playing the entire album. We're talking full surround sound, baby! And here we are, thinking we're cool because we've got noise-canceling headphones. Let's talk speed. Light is fast, like mind-blowingly fast. We're talking 300,000 kilometers per second. If you were a beam of light, you'd be circling the Earth 7 times in a single second. Imagine that. You could basically ghost all your problems before your friend even finishes reading your last text. Poof. Gone, like that awkward small talk at a party. And it's not just about speed. Light's got energy. The shorter the wavelength, the more energy it's packing. That's why ultraviolet light, the stuff that can give you a sunburn, is more dangerous than, say, the visible light you're seeing right now. Think of UV light as that overpowered boss in a video game. It's got extra energy, and if you're not careful, it'll wreck your day faster than you can say sunscreen. So, how do we see all this stuff? Well, it's not magic, it's your eyes. Your eyes have these cool little sensors called cones that detect red, green, and blue light. Think of them as your personal light DJs. When they all mix the colors just right, boom! You see white light like the kind you get from a super bright flashlight. But if they're only spinning one part of the track, like red or blue, you'll only see that color. Now, if you've ever wondered why the sky is blue, I've got the answer right here. It's because the shorter wavelengths of blue light get scattered more by the particles in the atmosphere. So when sunlight hits the sky, it's like nature's disco ball, scattering blue light everywhere. Pretty trippy, right? It's like the universe decided blue was aesthetic goals and just went with it. All right, now let's zoom out. Like, way out. Light isn't just what helps us see here on Earth. It's how we know what's happening out there in space. Stars, galaxies, black holes, they're all sending us light like cosmic postcards. And even though we can't see all of it with our eyes, we've got these crazy cool instruments like telescopes that can pick up all the other waves. Radio waves, X-rays, even gamma rays. It's like tuning into the universe's private radio station, but instead of music, we're getting data on stars exploding and galaxies colliding. How cool is that? And speaking of gamma rays, those are like the final boss of energy. If visible light is your chill playlist, gamma rays are that hardcore track you blast when you need to power through a last-minute study session. These waves have the shortest wavelength and the highest energy, which means they can do some serious damage. It's like, if you thought UV light was overpowered, gamma rays are like, hold my coffee. You definitely don't want to mess with those. Okay, so we've covered light speed, wavelengths, and how we see color. But here's where things get even more fun. Let's talk about reflection and refraction. Reflection. is when light bounces off a surface, like when you look in a mirror and see yourself staring back. It's kind of like taking a selfie, but with no filters. The light bounces off your face and hits the mirror, showing you the real deal. Yeah, it's a little less flattering than that Snapchat filter, but that's physics for you. Refraction, on the other hand, is what happens when light bends as it passes through something, like water. Ever stuck a straw in a glass and noticed it looks all bent and weird? That's refraction in action. Light slows down when it moves from air into water, bending as it goes. It's basically the same thing that happens when you're late to class and have to swerve through the hallway traffic. Light's just trying to find the quickest way through, even if it means changing direction. So to sum it all up, light is this epic force that lets us see, communicate, and understand the universe. It's energy in its purest form, zipping around at mind-bending speeds and carrying data from distant stars to your eyeballs. Every time you flip on a light switch or stare at your phone screen, you're witnessing the universe's most versatile tool in action. And remember, even though we can't see all of the electromagnetic spectrum, it's all around us, like invisible Wi-Fi for the cosmos. So, next time you see a sunset, take a second to appreciate that you're looking at light waves that have traveled millions of kilometers just to paint the sky for you. It's a cosmic connection right here on Earth. All right, my fellow paradox enthusiasts, that's it for today's episode of Paradox Hour. If your brain's not melted yet, be sure to follow, like, and share this podcast with your crew. And as always, keep asking questions, keep exploring, and remember, the future is always brighter when you understand how light works. I am your host, signing off. Until next time, stay curious and stay cosmic.